Alright, we're going to go and make a foldable here for the plate tectonics. First thing you're going to need to do is take your paper and fold it longwise or hot dog style down the middle. Take your time and make nice neat folds. Okay, once you have it folded in half, we're going to fold it into thirds. The easiest way to fold it into thirds is to kind of roll it up and then get to where it's this end's touching on the inside and the other end is right here on the outside, and that'll get you pretty darn close to being even, like that. Okay, and you're going to take your scissors and we're only going to cut one flap, not the whole thing, on the fold up to the fold, and on the fold up to the fold on this one. We've done this type of foldable before. Do not cut all the way through both sides. We want to be able to flip open the flaps like this and have this still be a solid piece of paper on this end. We don't want three separate foldables. So make sure you get that cut right. Alright, the first boundary that we're going to talk about here is going to be the convergent boundary. Okay, so on this flap we're going to write convergent boundary. Like that. Now, when we open this one up, leave the other ones closed so you know how much room you have to work with here. We're gonna, up top again, write convergent boundary. So when we're looking inside, we remember which one it is. Convergent boundary. Okay, now, the convergent boundary, remember, is where two plates come together, or as it said in the song, or collides, right? Now, just to help it stand out for us a little bit, I'm going to change color on the word collides, just so we can see that a little bit more. Okay, collides, and it's where subduction or uplift occurs. Because remember, it depends on which type of plates we have colliding of what happens, either uplift or subduction. So, just a basic drawing of plates here to show the movement. If those are my two plates and they're converging, they're going to go right towards each other like that. Alright, so if we're going to do, let's look at subduction first. Remember, subduction is when one plate slides under another plate. Okay, and how that's going to look is if we have an oceanic plate here, and a continental plate here. Okay, so maybe this one's got a mountain on it, like that. Add some water up here on this one for the ocean. Okay, the oceanic plate is going to go underneath the continental plate. Okay, so I'm going to take my orange here and draw my arrows for my plates moving. That one's moving that way, and that one's moving that way. And then right here, where it's sliding under the other plate, is where subduction occurs. Okay, so as it's going down underneath. So subduction is taking it down like that. Okay. Now the other type of convergent boundary is where uplift occurs. Let me get my orange back here. Uplift. And uplift is when two plates collide and force each other upwards. Okay, so we're going to have a continental plate on this side, like that, and a continental plate on this side. So we'll label those. Okay, so I've got my two continental plates here. So we'll draw our arrows showing which way they move. Convergent means they're going to collide. They're going to go right at each other like that. Now, when they collide, that's where this uplift occurs, making that particular mountain range there. Okay, let me zoom in for you there because I wrote uplift there in the middle in orange, so you can see that. Now, if we think back to our tectonic plates rap that we listened to, down at the bottom, I want to write the words that are going to help us. And we know that, according to the rap, convergent collide. Okay, oops, spelled that wrong. There we go. Convergent collide. So write that kind of big down there at the bottom. So for your convergent boundary, this is what you should have. So make sure you get all of that written and drawn and filled in. Alright, our next boundary, to close this one, is going to be the divergent boundary. Alright, flip that open, leave the other two closed so I know how much room I have. Right, divergent boundary up here. Okay. Now, remember, divergent boundaries are where two plates divide or split apart. Forming a mid-ocean ridge or a rift valley. So those are the two things we can form with a divergent boundary: mid-ocean ridge or a rift valley. Most divergent boundaries occur underwater. So that's our mid-ocean ridges. So if we're going to draw that, we're going to draw an oceanic plate. And another oceanic plate. Like that. And here's the little divide that it makes. Now remember, we have that molten rock from the magma come up and fill in this area, creating that new crust. And this is our mid-ocean ridge. Now, we have our arrows moving away from each other. So as those plates move, that's where all of this comes in, and our mid-ocean ridge is formed. Now, some occur on land, and that's where we get our rift valleys. So I'm going to make a continental crust and another continental crust with my valley in between. Alright, so there's my continental plates. And my arrows, they're going to move away from each other. And right here, they're usually kind of stair-stepped like this. This is our rift valley. Okay, and that's what you see on land. Now, since we're not in the oceanic plates and we're not so close to the mantle, we don't get that filling in like we do in the oceanic plates. Okay, we just have the big hole in the ground. So here's ocean water. Forgot to draw that in. So, at the bottom of this one, the words from our wrap: divergent divide. So this is what you need for divergent boundaries. So make sure you have that filled in before we move on to our last one. And the last one is transform boundaries. Okay. little bit here. Alright, so the transform boundary is where two plates slide. Is our key word on this one. Slide past each other. Often causing earthquakes. So here's my two plates. One going that way, one going that way. Okay, when these two plates move, so if here's a plate, they're not always straight, they have some jagged edges to them. So when they move, here's another plate. Like that. So when they start to slide, I have one going this way and one going this way. You're going to get points like right here and right here, okay? Points like that that catch. Okay? And that's where plates will catch on each other. Okay? And that catch builds up the energy, which then when it finally gives and blasts past the other one, it causes earthquakes. Like that. One other way to draw and show the transform boundaries is showing mountain ranges that are on transform boundaries that maybe go across transform boundaries. So if I have a plate right here with a mountain range on it, okay, like that, and I've got a plate right here, okay, you can see how when this plate is moving this way and this plate is moving this way, that our mountain range once lined up but has since moved past each other, okay, in the opposite directions, and so now the mountain range doesn't line up as well. Alright, so at the bottom of this one, the last part of our song, we say that transform tectonic plates slide. So there's your transform boundary. Now, if we open these up, oops, and I forgot something on divergent. Let me put my plates in here. Squeeze them in if you have to here. and draw our arrows. Divergent, of course, go in different directions. There we go, like that. So when we open the whole foldable, we can see all of the different plate movements and what they can create. And we have the words to our song: convergent collide, divergent divide, transform tectonic plates slide. You remember that, and you're good to go on the tectonic plates part of our upcoming test. So make sure you have that all filled in and use this to study with.